Hello, today we're going to take a look at the Chapter 2 practice exam. These problems will go through the entire chapter, so hopefully this will help you as you work through the chapter homework and help you prepare for the exam which is coming up. This is the first question. Show that each pair is a solution of the equation. Then graph the two pairs to determine another solution. So we have the equation y plus 2x equals 5. And we want to determine if 1 comma 3 is a solution to the equation. So remember, ordered pairs give you two numbers in a certain order, the order being x and then y. So the first number is the x value and the second number is the y value. So we're going to take those values for x and y, plug them into the equation to confirm that they make the equation true. So we're going to plug in 3 for y, and we'll plug in 1 for x, and then we will just simplify and hope that we get a true statement here, which would be 5 equals 5. And in fact, that is what we get. So we get 2 times 1, which is 2. And then 3 plus 2 equals 5. That is true, right? We get 5 equals 5. And so it works out. It's a true statement, which means, yes, this is a solution. And I'll just let you in on a little secret. It kind of gives it away in the directions. These will both definitely be solutions. It basically says in the directions, confirm that each of these are a solution to the equation. So the answer will be yes for both of them. But the way you check is by taking the numbers and plugging them in for x and y. So let's go ahead and do the second one. Same equation, we'll just do it over here. In place of y, we're going to plug in negative 5, plus 2 times in place of x, we're going to plug in positive 5. And that should equal 5 if it's going to be a solution, right? And so we'll simplify. 2 times 5 is going to be 10. We'll get negative 5 plus 10, which is going to be positive 5. And so again, we get a true statement, which confirms that, yes, this is a solution. What they want us to do is take those 2 points and graph them on the Cartesian coordinate system. So we'll graph 1 comma 3. See how good I can do this here. 1 comma 3, which would be right here. And 5 comma negative 5, which will be about right here. All right, so we plot those 2 points. This equation is a linear equation, which means the graph is going to be a line. And all you need to graph a line are 2 points. So we have these 2 points here. We'll connect them with a straight line. This is where I'm afraid my technology that I'm using here isn't going to be very helpful. I don't know how straight of a line I'm going to be able to draw. I'm kind of worried about that, actually. And I don't think there's a tool for graphing or for drawing straight lines. So I'm just going to have to, let me check over here real quick before I try this, because we'll probably need it later. No, that definitely isn't what I'm looking for. Close that. No, stylus. Yeah, I'm looking at all the different buttons I have around the outside that you guys can't see, and I don't see anything that says draw a straight line. So I'm just going to do my best here, connecting these 2 points with a straight line. Please don't laugh too much. Oh gosh, that's way off. I'm not even getting close to that other point there. So maybe I should start from down here and work my way up. Okay, that way wasn't too bad. All right, so that's the graph of this equation, right? Connecting those 2 points with a straight line. Unfortunately, that's going to make it difficult to do the last part here, which is find a third solution using the graph. So instead of being given the numbers, we're supposed to use the graph to help us find a third solution. And if I drew this relatively straight, we could probably determine another point somewhere on this line. And any point on this line should be a solution to this equation. But I'd have to be able to get that point in an accurate way, which I'm not going to be able to do with the graph I've drawn. Math Excel also doesn't really have the capability of accepting any kind of answer, so they actually narrowed it down for us and said, check negative 1 comma 7. That should be on your graph. So we have negative 1. I'm a little bit off the mark here, but it should be this point right here. So that should have been on my line if I had drawn it better. And they say confirm that this is also a solution. And again, the directions kind of give it away that yes, it's going to be a solution. But we could check in the same way. They want us to check by looking at the graph, but we could also check by plugging it into the equation. 7 for y, negative 1 for x, and you could check that you get 5 equals 5 here also. All right. So I spent a little bit more time on that one than I wanted to. I apologize. I'll try to keep it moving quickly. We have 20 problems to get through, so I don't want to spend too much time on any one problem. So we have y equals x squared plus 5. We want to graph this equation. The way we're going to graph this is by finding solutions to the equation. kind of like the last example, instead of being given ordered pairs to confirm them as solutions, we will have to come up with our own ordered pairs. And the way you do that is you get to pick one of the numbers, you plug it into the equation, and then let the equation tell you what the other number has to be. So you can pick whatever you want here. So a pretty good choice typically is 0. So I'll choose 0 for x, and then I'm going to plug that into my equation. So I'll have y equals 0 squared plus 5. And why did I choose 0? It was completely, I mean, I don't want to say it's completely random, but it was just my choice. I could have picked 1, I could have picked -1. I just picked 0 because usually it's pretty easy to work with. So here we get 0 squared, which is 0, plus 5, which gives me y equals 5. Right? And so I picked 0 for x. The equation tells me, okay, if that's what you want for x, then you have to let y equal 5 for it to work out. And so I'm going to have y equal 5, and that's going to give me one solution, right? That gives me one ordered pair, which I can then graph over here, 0, 5, which would be right about there. All right, so we could choose some other numbers. How many do we need to choose? Well, 2 points helps you graph a line, but this equation is not the equation of a line. This is going to be more complicated. So we're going to need probably 4 or 5 points to get a good sense of the pattern for this graph. So I'll choose x equals 1, x equals 2, x equals -1, x equals -2. Those are pretty standard choices and usually help you figure out what the graph looks like. Sometimes you need a little bit more than that, but this is going to work in this case. So I'll just do a couple more of these. I'll do a couple of the more difficult ones, and I'll let you fill in the rest. X equals 2, let's try that one. We'll plug that in for x, and we'll get, in place of x, 2 squared plus 5. 2 squared is 4. 4 plus 5 gives me 9. So I'll get y equals 9. And so I'll put that with the 2. That gives me another point, 2, 9. And I'm sorry I'm keeping this all in the same color. It is kind of nice to change colors, but that also takes a little bit extra time. So maybe I'll just kind of stick with using one color for some of these problems anyways. So that gives me this point here. And then let's try -1. All right, so we'll plug in -1. We'll do that here. X equals -1. Now it's a good idea because what you're really doing by choosing these numbers is you're sampling this equation, and you want to get a good sample, so you want to choose different kinds of numbers. You don't want to choose just positive or just negative, and you kind of don't always want to choose just small numbers. You might want to get 1 or 2 small numbers, 1 or 2 big numbers, because you want to find out what the equation's doing, and maybe it behaves differently when the numbers are small than when it does, sorry, I'm saying that wrong. Maybe it behaves differently when numbers are small than when the numbers are big. Right, so this one we can't really get too carried away because if we choose, for example, x equals 3, we get y values that are too large to graph over here. So we're going to keep them small so that they can stay within this window. So let's plug in -1. We'll get y equals, in place of x, we're plugging in -1 squared plus 5. -1 squared gives me +1. 1 plus 5 gives me 6. So I get y is equal to 6. And so that gives me the ordered pair -1, 6. So this is another one I'm graphing here. So -1, +6, which would be right here. And I'll let you do the work on these other two, but what you're going to find is that for +1, you also get y equals 6, and for -2, you also get y equals 9. And because there's a symmetry to this graph that you'll notice when you plug in numbers here. So we get these points here. And with those 5 points, you can get a pretty good sense of the shape of the graph. It's a parabola. It's a U shape. So again, I'll do my best to try to connect these points in that particular pattern. It's kind of hard to do on this tablet. Let's see, okay, that's not too bad. Maybe I just need to take my time with it and it'll go a little bit better. All right, so that's what the graph looks like. Okay, moving on to the next one. Okay, determine whether the correspondence is a function. So remember, a function is anything where the domain, where each value of the domain corresponds to just one value of the range. So here's my domain. These are like your x values. So we have x equals -5, x equals 1, x equals 7. And here's the range, which are like my y values. And it's a function as long as for each value of x, there's just one possible answer for y, one corresponding value for y. So you can kind of do some experiments here and ask yourself, well, when x is equal to -5, how many answers can I have for y? Well, according to this map here, when x is -5, the answer for y is going to be +4. And so you just get one answer, right? You pick this value of x, you get one answer for y, which is good. That's what a function should do. But it has to work that way for every value of x. So let's try another one. Let's try like x equals 7. Let's try that number. When I choose that value for x, how many answers can I get for y? There's only one possible answer for y, which is, again, 4. And so no matter what value I pick for x, I'm only ever going to get one answer for y, and so that makes this a function. So the answer is going to be yes. Now here we have two choices to make. There's two yes answers. So we have to read these carefully here, and sometimes these trick me, so let me take my time with this. Yes, because each element in the range corresponds to exactly one element in the domain. That's backwards, right? What I said up here was that each value of x, each value in the domain, can only correspond with one value in the range. So let's read this other one here. Yes, because each element in the domain, that's x, corresponds to exactly one element in the range, that's y. That is what makes it a function. Each value of x corresponds to just one value of y. All right. All right, so this problem, we're practicing using function notation. And the way function notation works, what's nice about it is it gives your equation a name. So this equation has the name f of x. The f of x took the place of the y variable. So the equation originally was y equals absolute value of x minus 4, but they replaced the y with this f of x. You could also use g of x, you can use h of x, and so if you have multiple equations, you can give each one a different name. One of them you can call f, one of them you can call g. So that's one value of the function notation, is that it lets you label the equations. And so when I want you to use equation f, I'll put that here. I'll put f of 3, for example, and it tells me to use equation f. If I wanted you to use equation g, which isn't listed here, but if there was another equation, we could call it g, and then I could say find g of 5. And you would know to use that other equation. All right, so this tells me which equation to use. I want to use equation f, and in place of x, they are plugging in the number 3. And so that's telling me what they want me to plug in for x. So in place of x, we're going to plug in the number 3. So let's just write the equation here. F of x equals the absolute value of x minus 4. They want me to find f of 3. So they're replacing x with 3 in the function notation. That means I want to replace x with 3 everywhere else in the equation. Let's try that again. All right, so absolute value. In place of x, I'm going to do the same thing. Plug in 3 minus 4, and then I'm going to simplify. So I get the absolute value of 3, which is 3. 3 minus 4 is negative 1. And so that's going to be my answer. F of 3 is equal to negative 1. Some students think, well, I have to solve for f by dividing 3 on both sides, but the 3 is not really there mathematically. It's just, the analogy I like to give is it's a pop-up window, or it's an information window, and it's just letting you know what was plugged in for x. It's not actually there mathematically. So f is already by itself. The 3 is just there for informational purposes, and it's letting you know that when you plug in 3 for x, you're getting negative 1 for y, because remember, this is the y variable, right? So this is the end of the line. That's my answer, right? Negative 1 is the answer. Okay, so you do the same thing with f of 4. I don't think that one's too complicated. I'll let you do that one on your own. It's the same thing, except you put a 4 here. C is a little bit more complicated. It looks worse, but it actually is a little bit easier because this is something you really can't simplify. So the answer looks kind of scary, but it's kind of nice because there's no work to do beyond just plugging this in. So what we want to do, same thing we did over here for part A. For part C, I'll write the function down. F of x equals the absolute value of x minus 4. And what they're asking me to find is f of a plus 4. So whatever they're putting in the parentheses here, that's what they want you to plug in for x. So I'll do the same thing on the right-hand side of this equation. For x, I'm going to plug in a plus 4. And then everything else is going to stay the same. So the absolute value symbol is going to get copied down. The minus 4 gets copied down. And then I would simplify, but nothing here can simplify. The absolute value because that's still a variable here, the absolute value prevents us from being able to simplify anything. So this actually is the way you keep it. So that's what I mean by it's a little bit easier because it's complicated enough that nothing's going to simplify, so there's no further work that I have to do. So that would be my answer to part C. Sorry, I wanted to take a sip of coffee there real quick. All right, let's take a look at the next problem. Graph the function f of x equals negative 7 plus absolute value of x. So we have f of x equals negative 7 plus the absolute value of x. I want to write that out so that I can remind you again that this function notation is just the y variable. So it's y equals -7 plus absolute value of x. And while this is a different kind of equation, it's really a repeat of the problem that we did earlier with x squared plus 5. To graph this equation, we just need to find a handful of solutions, plot them as points, and see what the pattern is. And in fact, here they're even guiding us further by not only setting up a table for us, but they've already chosen the values that they want us to use for x. So we just take these x values, plug them into the function, and then the function will tell us the corresponding value of y, which we're going to put in the right-hand column here. All right, so again, I'm not going to do all of these. I'll just do a couple. I'll do -2, for example, because that one looks a little bit scary. Be careful with the absolute value here. So we're going to plug in -2 for x. I'm going to plug that into the function notation. And then I'll also plug it in on the right-hand side of the equation. Plug in -2 everywhere I see an x. And so I'm going to simplify. We get -7 plus the absolute value of -2 is +2, right? That's what the absolute value does. It makes numbers positive, right? And then -7 plus 2 is going to give me -5. And so we'll get -5 here for that. That gives me the point -2, -5. So let's go ahead and plot that point, -2, -5, which is right there. All right, so let's do 0, and then I'll do +1, and then I think I'll let you do the rest. So you plug in 0 for x, we'll get f of 0 equals -7 plus the absolute value of 0. This will be -7 plus 0, which is going to be -7. Right? So the absolute value of 0 is just going to be 0. And so we get -7. That'll be the corresponding value for y. This gives me the point 0, -7. So let's go ahead and plot that point here. Let's try x equals 1. Plug that in. We'll get f of 1 equals -7 plus the absolute value of 1. Sorry, this is all I'm kind of writing slanted for some reason. I don't know why. The absolute value of 1 is still 1, right? Absolute value just keeps it positive. And we'll get -7 plus 1, which is -6. So I'll put -6 here. And we'll get 1, -6, which is that point right there. And like I said, I'll leave it as an exercise for you to fill in the rest of these, but this one also has that same kind of symmetry we had in the other problem. This one will also be -6, this one will also be -5. And so you get these points here, this point here, and this point here. And so this time the shape, it kind of looks like a parabola, but it's actually a little more rigid than that. The shape of this graph is a V shape because you see these points here are lining up in a perfectly straight line. So we get a straight line going this way. All right, that didn't turn out too bad. And these points are also lining up in a straight line, but going in this other direction here. So we get a straight line going this way. And so my graph is a V shape. All right, let's take a look at the next problem. Determine if this graph is a function. This will be one of the easiest problems on the test. It's a yes or no question for one thing. But to determine if a graph is a function, you want to use what's called the vertical line test. And it's one of the easiest things you'll do in this class. So what you do is you just draw imaginary vertical lines through the graph to see how many times the vertical line will cross the graph. So I'll do, like, let's say this one right here. Okay, so here's a vertical line. Try to make it as vertical as I could. How many times is it crossing the graph? It's crossing it 2 different times. Once up here, once down here. If the vertical line crosses the graph more than once, then it's not a function. Right? So this crosses more than once, and so this is not a function. All right. I'm sorry, that's supposed to be an arrow, but I'm not very good at drawing arrows, so it's not a function. All right. So the answer here is no. The reason is, if we go back to what I said about functions earlier, this vertical line represents a particular x coordinate, whatever that x coordinate is right there. So this vertical line is picking a value for x. The number of times it crosses the graph is the number of corresponding y coordinates that value of x has. So we're seeing on this graph that this value of x has 2 different y coordinates. That's 1x with 2 different answers for y. That's why it's not a function, right? To be a function, each x can only have 1 corresponding value for y, but this x has 2 corresponding values for y. So it's not a function. All right. Now this one, we're going to use the graph to answer these questions. F of 3, so remember, when you have this function notation, f of 3, the number in the parentheses is your x value. right? So they're setting x equal to 3, and if they want me to find f of 3, they're asking me to find the y value. So they want to know what y is equal to when x is equal to 3. So I go over here to my graph, find 3 on the x-axis, find the corresponding point on the graph with the x-coordinate of 3, which would be this point right here, right? So this is the point on the graph where x is equal to 3, and then I look to find what the corresponding y value is, which in this case is 2. And so that is the answer I'm looking for. So you want the y-coordinate from the point on the graph that has this particular x value, right? X equals 3 has the corresponding value of y, 2, when you look at the graph, right? Find the domain. So to find the domain of a graph, the easy way to do that is to ask yourself, how far to the left does the graph go? How far to the right does it go? The domain is asking you, what are all the possible values of x in this graph? What is it possible for x to equal? What are all the x coordinates? This graph we see by these arrows is going to go forever to the left, and it's going to go forever to the right. So how far to the left does it go? It goes forever to the left, negative infinity. How far to the right does it go? Forever to the right, which means positive infinity. So the domain is all real numbers. In interval form, it's from negative infinity to positive infinity. This is the way I prefer to write it, but I'm not given that choice over here. And so I have to make sure I can translate that to this. That's all real numbers, right? Negative infinity to infinity. Okay, better use a different color for this next question. So this one is the same idea as the first one, except in reverse. So they're telling me f of x equals 1. They're giving me the y value, right? F of x is the y value. So y is equal to 1. That's what they're telling me. And I'm trying to find what x would equal to give me that particular y value. So I'm going in reverse. I'm given the y coordinate, and I want to find the corresponding x coordinate that matches that y coordinate. So I go to my graph where y is equal to 1, which is on the y-axis, which is right here. And then I find the corresponding points on the graph with that particular y coordinate. So that'd be this point here and this point here. There's actually 2, right? So both of these points have a y coordinate of 1. This point is 6, 1, and this point here is 4, 1. What I'm looking for are these corresponding x coordinates that match up with y equals 1. So I actually have 2 answers here. We have 4 and we have 6, right? Those are the 2 different values of x that give me a y coordinate of 1. So x could either equal 4 or it could equal 6. So those would be my 2 answers that I would type into the box right here. Okay, and then the last part, which is kind of hard to see, but I made sure when I snapped this picture, because this is just a picture, I can't actually scroll down, but I made sure it at least had the directions on there, even though it doesn't have the multiple choices. What is the range? Now remember, the range is all the numbers that y can equal. It's just like the domain except for the y variable. So what are all the possible values for y? What are all the y coordinates in this graph? To find the range, you want to ask yourself, how far down does my graph go? How far up does it go? And if we look at the graph here, there actually is a limit. It only goes down so far. It only goes down as low as this point right here. And what we want from that point is the y coordinate. The range is interested in what the values for y are. And so in this case, the y coordinate here is 0. And it's a very common mistake. Students will pick 5 because that's the number they see close by. But that's the x coordinate for this point. That's related to the domain, right? The range cares about what the y coordinate is, and the y coordinate here is 0. So that's as low as it goes. It goes as low as 0. And how high does it go? Well, it goes up forever, right? That's what these arrows indicate. So it's going to go up to infinity. So my range in interval notation would be from 0 to infinity. Now I have a feeling your multiple choices down here are going to be set up like this. So the answer you want to choose is the set of all y such that y is 0 to infinity as an inequality would be numbers that are greater than or equal to 0. Right, so you want to choose the greater than or equal to, and then in the box you're going to type in 0 because that's how you describe this set of numbers. It's all the numbers bigger than 0 or equal to 0. All right, so this is what the range would look like. Okay, let's look at the next example. How are we doing on time? 25 minutes? I don't even know if I'm quite halfway yet, so hopefully I'm trying to keep this video to like 50 minutes because this is something, a class period is typically 50 minutes, and reviewing a test should take about a class period, so that is what I'm hoping to do as my goal, but I might go a little bit over that. Find the domain of this function. We're not being asked for the range, just for the domain. And as I mentioned before, the domain is all the numbers that x is allowed to equal. So we want to know everything that could be plugged in for x here. When you have a fraction, the one thing you have to avoid is dividing by 0. So the one thing that I absolutely cannot allow to happen, so here's what's not allowed, is for the denominator, right? It's not that x can't be 0, the denominator, x plus 11, cannot equal 0. That's the one thing that's not allowed to happen, because if that equals 0, we get 14 divided by 0, which is broken, right? That is undefined. It breaks the equation. It doesn't produce any valid results. So we want to avoid this situation. So when x plus 11 equals 0, that's the thing that's not allowed. So that's what I like to do is I take the denominator, I set it equal to 0 because that's what's not allowed to happen. And then I solve for x, and it tells me what x is not allowed to equal. So I'm going to solve for x by subtracting 11 from both sides, and I get x equals negative 11. This is what x is not allowed to equal. And so the domain is everything but this number. The domain can be any other number for x except for negative 11. That's the one thing x is not allowed to equal. So I'm not sure I cut that off. I should have put that here. I'm not sure how they want you to format this answer. So it could be something to the effect of x, the domain is the set of all x such that x is not equal to, and then you have a box here, and in that box you'll type in negative 11. Or you could say it's all real numbers except x equals negative 11. That's the one exception. Anything else works. So I'm not sure which way they might set it up on Math Excel. I apologize that I didn't save that on my screen. All right. You could also write it as an interval. So I guess if I'm covering all my bases here, let's go ahead and do this one. As an interval, we want to avoid negative 11, but any other number works. So I like to look at it on a real number line. I'm skipping over negative 11, but any number to the right of negative 11 can be plugged in for x. Any number to the left of negative 11 can be plugged in for x. So to write this as an interval, this goes from negative infinity to negative 11. And this one goes from negative 11 to positive infinity. And that way we're skipping over negative 11, and we join those two sets together using a union symbol. All right, so this is what it would look like as an interval. That might come in handy later. All right. So let's try another problem. All right, so this one, asking the same question, what's the domain? But this time, we're not dividing. It's not a fraction. There's no risk of dividing by 0 here. And so when you're looking for the domain, you kind of, the domain is what x is allowed to equal, but the corollary that goes with that is, what is x not allowed to equal? Is there anything that I shouldn't plug in for x? And the two restrictions that you need to be aware of are you can't divide by 0. So if you have a fraction, make sure you're not picking an x that makes you divide by 0. That's not a concern with this problem because this problem doesn't have a fraction. There's no way to divide by 0 here. The other one, which you're not going to see in this chapter, is you don't want negative numbers inside of a square root. This equation doesn't have a square root, so there's no risk of getting a negative in a square root either, right? So this problem, we can't divide by 0. That's just impossible because it's not set up where that could happen. And we can't take the square root of a negative. And so there's no concerns, which means we can plug in whatever we want. We don't have to have any worries. We're not going to divide by 0. We're not going to get the square root of a negative. There's no limitations on this equation. There's no limits, which means the domain is just all real numbers. D, right? So if there's no concerns in the equation for ways that it could break or not work out properly, then the domain is just automatically all real numbers. That's where I start with every problem, is I'm going to assume the domain is all real numbers until I find evidence to the contrary. And when I find evidence to the contrary, then I make adjustments. Okay, like in the last problem, I can't choose negative 11. So I start off with the assumption that x can be anything that I want, but then I found evidence that actually negative 11 doesn't work. So I remove that number, leave everything else there. Right, that's a good way to think of it. All right. Find the slope and the y-intercept. So to do that, so we've moved into the territory of linear equations. And to find the slope and the y-intercept from an equation, you want to set up your equation in this form. It's the slope-intercept form, and the way you get it in that form is you solve the equation for y. So I'll start by subtracting 4x from both sides, and I will get negative 3y equals 11 minus 4x. So don't forget that negative sign in front of the 3y. That gets copied down as well. And then to solve for y, I'll divide by negative 3 on both sides. So divide by negative 3 here, divide the entire right-hand side by negative 3. So this gets y by itself. Now, that's solving it for y. So if you wanted to be technical about it, you've done what I've asked you to do. You solved it for y, but it doesn't quite match up to this formula very well. What we want to see on the right-hand side are two distinct terms, not one giant fraction. So what we're going to do is take the negative 3, divide it into each term individually, essentially taking the big fraction and splitting it up into two separate fractions. So what we're going to get is we'll get y equals, we'll get 11 over negative 3 minus, because we have a minus sign right here, 4x over negative 3. And so that's better, right? We have two separate terms, so it's going to make it a little bit easier to match it up to this formula here. But it still needs a little bit of work. So the first number, there's not much we can do. 11 over negative 3, that's just negative 11 thirds. Right, that's just going to stay the way it is. But this one, we have a double negative here. So what's going to happen is those negatives will cancel each other out and we'll get a positive. And then to make it match more perfectly to the formula, instead of leaving the x embedded in the fraction, we can just kind of write it off to the side of the fraction. I know that's not a very mathematical description of what you're doing, but essentially knock the x off to the side of the fraction. And so we'll have 4 over 3, that'll be my fraction, and the x gets written off to the side. So it's not a very mathematical explanation, but it mathematically works. And so this is the way you want to format your equation. From here, we can determine the slope and the y-intercept by just reading this equation. The slope is the number being multiplied to x. So I have it in a slightly different order, but it's still easy to identify. It's the number in front of x. So this is my slope, which is indicated with an m, and this is my y-intercept, the constant term that's by itself. And so you type this in for the slope, 4 thirds, right? So you type in 4 thirds here. And then the y-intercept is 0, comma, whatever this number is here, which is negative 11 thirds. Let's take a look at the next problem. Find the slope of the line indicated in the graph. There's two ways you could go about doing this. You could use this formula, which I think we're probably going to use on the next problem, if I'm not mistaken. y2 minus y1 over x2 minus x1. So that's a formula that you need to know for the test. So make sure you have that formula memorized because it's not given to you on the test. I expect you to know that. You could use this formula by using these 2 points here. We have this point here, which is 0, 6, and we have this point here, which is 5, 7, right? And you could plug those 2 points into this formula, and it works fine that way. That's the way I normally would teach it. At least I did for several years. But when students found out there was an easier way to think of the problem that got them the right answer, I feel like whenever that happens and students find out about it, they stop trusting my explanations. And so I want to make sure I retain your trust on these problems. So the easy way to do this is to think of this as rise over run. Right? Rise is the change in the vertical direction. Run is the change in the horizontal direction. And we can just, how do you say, you don't have to calculate it. You just count off the rise and the run from the graph. So you don't have to plug numbers into a formula. All you have to do is find the vertical and horizontal change between these 2 points, and that's your rise and run, and you just divide the two. Right? So going from this point to this point, the vertical change is 1, right? It's going from 6 up to 7. So the rise here is 1, and then the run, it's going from 0 on the x-axis to 5 on the x-axis. So the run is 5. So the vertical change is 1, the horizontal change is 5. That's my rise, that's my run. And so my slope, I just divide those two, right? The rise is 1, the run is 5. And so my slope will be 1/5. Let's try that 5 again. All right, okay. All right, so the slope is 1/5. So that's how I would find the slope from a graph. You know, count the rise, count the run from the graph, and then divide the two. Right. Now, one thing I should say, this one worked out kind of nice. We didn't have this issue. But if you go in a negative direction, if you go down or to the left, that is a negative rise or a negative run. So make sure you use the right sign depending on whether you're going up or down or left or right. So if you're going to the right, it's positive. If you're going to the left, it's negative. If you're going up, it's positive. If you're going down, it's negative. That will be important for slope as well. All right, so find the slope of the line containing the following pair of points. So we don't have to find the equation, just the slope. This one is where you use this formula here that we just talked about. y2 minus y1 over x2 minus x1. We're going to label the points. At least that's the way I like to do it. So this is my first point. This is the x coordinate. This is the y coordinate. And for my first point, I'll label those with 1s. Here's my second point. This is the x coordinate. This is the y coordinate. And since it's the second point, I'll label those with 2s. And then I plug them in the way I've labeled them. So y2 is negative 6 minus, because there's a minus sign in the formula. I didn't write it very well, but that's a minus sign. And then y1 is negative 1. So I use parentheses because I have the double negative there. I want to make sure I handle that the right way. And then x2 is 5 minus, from the formula, x1, which is 8. And so this is going to be negative 6 plus 1, because the double negative makes that a positive, over 5 minus 8. That's going to give me negative 5 on top, negative 3 on the bottom. And some students will kind of stop there, but even though the numbers don't reduce, the negative signs can be canceled out, right? So negative divided by negative, which makes it positive. So we get positive 5/3 as our slope here. All right. Find the rate of change. So for this particular problem, I've lost count of what number problem this is, but there's a few different versions of this problem that could show up on the test. So this was the one that I happened to get when I generated the practice exam. There's a couple other ones. There's one with a treadmill. There's one with a house. And so they have different names. So for a house, they ask you to find the pitch of the house. For the treadmill, they ask you to find the, what is it called? I can't remember the name of it now. The grade of the treadmill. For this graph, they're asking us to find the rate of change. All of these problems are just finding slope, right? So if they ask you to find the rate of change, that's the slope of the line. If they ask you to find the grade of the treadmill, that's the slope of the treadmill. And they'll have a diagram there that kind of shows you it's a line and there's two different numbers. There's a rise and there's a run, and you just divide the two. Same thing with the roof, right? So here we can count. We can count the vertical change and the horizontal change, and that'll be my rise and my run. So I'm just going to do it that way. Right? Rise on top, run on the bottom. They gave me several points here they've marked. I just need to pick 2 of them, and it doesn't matter which 2 you pick. You'll get the same answer either way once you reduce your fraction. So I think probably it'd just be easier to use the first 2. So I'm going to pick these 2 points and then measure the vertical change. So how much is it changing vertically? I'm going from 42 to 36. Now this is in hundreds of dollars. So really this is 4,200 to 3,600. So make sure you notice the units there. So that is a change of $600, right? We're going from 4,200 to 3,600, but it's a negative change. It's dropping from 42 down to 36. So the run here is negative. I'm sorry, it's not the run. The rise here is negative, right? So we have a rise of negative 600 because it's dropping by 600. The run is the horizontal change. It's going from 0 to 1, right? And so that's just a change of 1. And it's positive because it's going to the right, so it's a positive 1. And so I divide the rise over the run, and that gives me negative 600. And that is the rate of change. And if you want to put some units on it, I think MathXL just kind of puts it there for you, but this is negative $600 per year, right? You just take the units of these and divide them. So this will be dollars per year. And that's the rate at which this thing is changing. The value of this particular computer is losing $600 every year, right? The older it gets, the less valuable it is. All right. So that is the slope of that. Find the intercepts and use them to graph the equation. So again, we're back to graphing lines. To graph a line, all we need are 2 points. The intercepts will give you 2 points. To find, there's 2 types of intercepts. There's the x-intercept. The way you get the x-intercept, the first step is to plug in 0 for y. So we'll plug in 0 for y. I'm sorry, I forgot the negative sign. Let me get that in there. So we get negative 28 plus 4x. The reason we're plugging in 0 for y is because we're looking for the point on the graph where it crosses the x-axis. And for it to cross the x-axis, the y-coordinate would have to be 0. Right? For the point to be on the x-axis, the y-coordinate has to be 0. So that's why we're plugging in 0 for y. And then we're going to solve for x to find out what the x-coordinate is for where the graph is crossing the x-axis. All right, so we get 7 times 0, which is 0, equals negative 28 plus 4x. Now we're going to solve for x. And so we will add 28 to both sides. And we'll get 28 is equal to 4x. And then we'll divide by 4. I'll just keep the same color here so I don't have to keep going back and switching it. We get x is equal to 7. So that is the x-intercept, and it's very common to say, oh, the x-intercept is 7. But the proper way to describe the x-intercept is as a point. The x-coordinate is 7. The y-coordinate is 0. Right? That's what we plugged in for y. So we get the point 7 comma 0, which is on the x-axis, where it's supposed to be. Right? The x-intercept is supposed to be where the graph crosses the x-axis. So the point should be on the x-axis. All right, y-intercept, same idea. It's the point where the graph crosses the y-axis. To be on the y-axis, the x-coordinate would have to be 0. So the first step here is to plug in 0 for x. So I'll have 7y equals negative 28 plus 4 times 0. We're going to plug in 0 for x. And then step 2, solve for y to find the corresponding y-coordinate. This is just going to be 0. Negative 28 plus 0 is going to be negative 28. So we're going to get 7y equals negative 28. Divide by 7 on both sides to solve for y. Sorry, don't know what I'm doing there. And we'll get y equals negative 4. Right. That's the y-coordinate. So the proper way to write your y-intercept is as an ordered pair. The x-coordinate is 0. The y-coordinate's negative 4. And so that is my y-intercept. So we get 0 comma negative 4, which is this point right here. Let me use the same color. And then to graph the line, we just draw a straight line connecting those 2 points. And so let's see how badly I will butcher this. So let's try to go slow here. Yeah, that wasn't too bad, I guess. All right, and then we'll go, okay, I missed it there. Okay, there we go. All right, so your line should look something like that. When you're taking the test on Math Excel, if you're taking it on the computer, it draws the line for you. You just plot the 2 points and the program automatically draws your line, so you don't have to worry about how good your line is drawn. All right. Let's see. Graph using the slope and the y-intercept. So we kind of did this exercise already. This is already in slope-intercept form, so that helps a lot. We don't have to actually do any work here. We can just read the slope and the y-intercept straight off the equation. Right? The slope is negative 6 over 5, and the y-intercept is 0 comma negative 7. Right? So this is b, this is m. That's how we get that information. To graph using that information, we start by plotting this point, because you have to start from a point that you know is already on the graph. This is not a very nice one for them to have given us, because you see the y-axis here is going by 2s, and my y-intercept is an odd number, so it's not going to be right on a line here. So be careful about that. This is negative 4, that's negative 6, this is negative 8. So negative 7 is going to be halfway in between negative 6 and negative 8. So it's going to be about right there. From there, we use the slope as like a map to help us find a second point. We're using the rise over the run again, right? And so the rise is negative 6, which means we're going to go down 6 from this point right here. And the run is 5, which means we'll go to the right 5. All right, so that's my map. That's my set of directions that tells me how to find a second point on the line. All right, and so we're going to go from here down 6. So we're at negative 7. Down 6 gets me to negative 13, which would be about right here. And then to the right 5, which is another cruel one because this is also going by 2s. So it's going to be right in the middle of this square right here. All right. On Math Excel, as you're doing this on the homework or on the test, as you move your cursor around, it will tell you the coordinates for where your point is going to be marked. So just make sure you're looking to make sure it lines up with negative 13, right? Because we're going down 6 right here. So that's negative 6, down 6, and then to the right 5. So it should be at 5 comma negative 13 is where your point should end up, which would be about right there. And then Math Excel automatically draws in the line for you. Let me see how I can do with this freehand. So we'll connect these 2 points with a straight line. Okay, that wasn't too bad, I guess. And then something like that. All right, so that's what your graph will look like. So that's how you graph using the slope and the y-intercept. All right, now this one's a bit of it's not a trick question, but this is a special case. So if you have y equals a number like this, that's supposed to be a pound sign. Let me try that again. If you have y equals a number, any number, then the graph will be a horizontal line that passes through that number on the y-axis. So that's exactly what we have here. Y equals -3. So here's -3 on the y-axis, but you have to realize it's not just a point. We're graphing a line here. We're graphing the equation as a line. So this is one point on that line, but we want all the points where y is -3, which will be this entire horizontal line right here. All the points to the right. Sorry, I didn't draw that very well. All the points to the left. I don't know what it is. I think my hand got in my way there, but all these points right here all have a y coordinate of -3, and that's what they're asking for. Find all the ordered pairs where y is -3. This is where they're all located, on this horizontal line right here. For a horizontal line, the slope is 0. Now, for this version of the practice exam, I happen to get y equals a number, but you could just as easily get x equals a number instead. And in that case, the graph will be a vertical line that passes through that number on the x-axis. So it would go vertical like this, passing through whatever number they give you. And the slope here would be undefined if it's a vertical line. All right. So the slope would be undefined. And so notice they're asking for that information down here. So for us, the slope being 0, we just type in slope equals 0 here, and we choose option A. For the vertical line, if we had gotten a vertical line instead, we'd choose option B. The slope is not defined. All right. Determine whether the graphs of the two equations are perpendicular. So to determine if something is parallel or perpendicular, we look at the slope. And to be perpendicular, the slopes would have to be negative reciprocals of one another. Negative reciprocals. So I need to find the slope of these two lines. Since I'm given the equation, the way you find the slope of a line, given the equation, is to solve it for y. Right? We have to get it in this form, y equals mx plus b. So we make the equation look like that, and then we can get the slope off of the equation. So I'm going to solve this for y, just like we did earlier. Subtract x from both sides. We get 2y is equal to 7 minus x. Oops, sorry, don't know what I was doing there. 7 minus x. Divide by 2 on both sides. And we get y is equal to, remember what we did last time, divide the 1/2 into each of these. Not the 1/2, sorry, I'm kind of thinking ahead there. Divide the 2 into each term, so we get 7/2 for the first term, and then minus x over 2 for the second term. But we want to put the x off to the side of the fraction to make it fit that formula a little better. And when I do that, since there's not a number here, we put an invisible one. It's not an invisible one, but we put a 1 there. There is an invisible one here to begin with. When we move the x off to the side, it's not invisible anymore. We have to actually write the 1 in there. So my final equation should look like this. Y equals 7/2 minus 1/2 x. Right. So the slope here for this equation is negative 1/2. Right. So that's the slope of the first equation. We need to similarly look at the second equation, and I might just, I don't know, I'm trying to think, should I work it out? I guess I should go ahead and try to work it out. So let me get started here though, because I'm running out of space. So we'll subtract 2x from both sides. I was going to say maybe you could go ahead and do it as the student. I did the first one. It's very similar how you do the second one, but I don't know, there might be some differences here. So let me go ahead and actually work it out. All right, subtract 2x from both sides, divide by 4 on both sides. The 4 divides into both of these, so we're going to get y equals 9 over 4 minus 2x over 4. And then we will put the x off to the side of the fraction, and then reduce this fraction while we're at it. And so we get y equals 9/4 minus 1/2 x. Right? The 2 over 4 reduces to 1/2. So the slope here is also negative 1/2. So they are not negative reciprocals of each other. Negative reciprocal would be, for example, if I had 2/3 and negative 3/2. Right? Those are negative reciprocals. the way they become negative reciprocals is they have to have opposite sign. One's positive, one's negative, and they have to be flipped over versions of one another. So like when you take the reciprocal of a fraction, right? The reciprocal of 2/3 is 3/2, but they also have to be negatives of one another, which means opposite sign. All right, so 2/3 and negative 3/2 is an example of what negative reciprocal looks like. These are not negative reciprocals. In fact, they're the same. They're equal, which means the lines are in fact parallel, right? So parallel lines are lines that have the same slope. So these two lines actually would be parallel, not perpendicular. So the answer here is no. So even if they're not the same, if they're different, so let's say I had gotten -1/2 here, and I got, let's say something like 5 over here. They're not parallel if you get 5, but they're also still not perpendicular because they're not negative reciprocals, so they would be neither. They're not parallel, they're not perpendicular. So that can happen. In fact, most lines are going to fit that description. They will be neither parallel nor perpendicular. Right? Parallel and perpendicular are special relationships between two lines that only occur in very special exceptions. Right? So in general, if you just pick two random lines, most likely they're not parallel and they're not perpendicular. Right? These happen to be parallel. But anyways, to be perpendicular, you have to have the slopes be negative reciprocals. And I think I've belabored the point a little too much, so I'll just move on to the next example. All right, so these next several questions, I think there's 3 or 4, so we're getting pretty close to being done. I'm also at my 50-minute mark, so I'm sorry I went a little bit over the time I would have liked. These next few questions, we're finding the equation of a line. And there's 2 ways you can do it, but just for simplicity's sake, I'm just going to stick with one technique. Let me at least mention what the other technique is, but I'm not going to do the problems in this way. You could also use this formula. Y minus y1 equals m times x minus x1. If you elect to do the problem using this formula, then that's another formula that you would need to memorize. So this is a perfectly valid way to do the problem, but I honestly prefer this method using y equals mx plus b, and that's one less formula that I'll need to know. So here m is the slope, b is the y-intercept. They tell me the slope is 6, so that's my value for m, so I can just go ahead and plug that in right away. We'll get y equals 6x plus b. B is the y-intercept, which is not the same as saying it's a y-coordinate. So I'll get a lot of students on the test that'll say, oh, -7 is the y-coordinate here, and they plug that in for b, and that is incorrect. B is the y-intercept. It's a very special point. And the y-intercept has to start off like this, 0, some number. If they give you a point where the x-coordinate is 0, then yes, that would be your value for b. This does not have an x-coordinate of 0. This is not the y-intercept, so this is not b. I don't know what b is equal to. How do I find out what b is equal to? I take this point, and instead I plug it in for x and y. So in this formula, it's an x-coordinate and a y-coordinate. I'm going to plug those numbers in for x and y here in this formula. Then I can solve for b and find out what b is equal to. All right, so y is -7. X is -5. So I plug those two numbers in. I'm sorry, I'm writing sideways again. And then I'm going to solve for b. So I'm going to get -7 equals -30, right? 6 times -5 is -30 plus b. Then I solve for b by adding 30 to both sides. Plus 30, and so we're going to get 23 is equal to b. So the y-intercept is 23. Right? That wasn't given to me. I had to calculate it. Now that I know what the y-intercept is, I come back to my formula, and I plug in the information that I have. And so I'm going to have y equals 6x plus 23. That's my final answer. All right. These are going to get progressively more complicated. So this one, they just gave me the slope. That helped a lot. This next one, they're not going to give me the slope. Instead, they give me 2 points. And I'm going to have to calculate the slope. So again, I still want to use this formula, y equals mx plus b. But to get started, I need to know what m is equal to. And they didn't tell me what m is equal to this time. I'm going to have to calculate it using this formula, y2 minus y1 over x2 minus x1. So I'll label my points before I plug them in. So this is my first point. This will be x1, y1. This is my second point. So this will be x2, y2. Plug the numbers in the way I've labeled them. So y2 is 7 minus y1, which is 5, over x2, which is 6, minus x1, which is 2. And then I'll simplify. So 7 minus 5 is 2 on top. 6 minus 2 is 4 on the bottom. And I'll reduce, because anytime you have a fraction, you want to reduce it. And I'm sorry that, I don't know if you can see it, but I had a pop-up message show up. I think it's actually, I don't think it got recorded, but sorry about that if it got in the way. And then, so the slope is 1/2. So now we know the slope, so we can go ahead and plug that into our formula. So I have y equals 1/2 x plus b. I still don't know what b is equal to. They didn't give me the y-intercept, so I have to do what I did on the last example. I have to take a point and plug it in for x and y. You have 2 points to choose from, and it doesn't matter which one you choose. You'll get the same answer for b, regardless of which point you decide to plug in. So I usually choose the one that looks the friendliest, the one with the smallest number. So I'm going to choose this one, 2, 5. I'll plug in 5 for y, and I'll plug in 2 for x, and then I'll simplify. Right? And so here, if you want to think of this as 2 over 1, the 2's cancel out, but it doesn't just disappear. We still have 1 over 1 here, which is equal to 1. So we'll have 1 plus b is equal to 5. Subtract 1 from both sides, and I get that b is equal to 4. Now that I know the y-intercept, I will come back to my formula and plug that in here. And so my final answer is going to be y equals 1/2 x plus 4. Now if b comes out negative, you don't want to put, like if b was -4, you wouldn't want to put plus -4. You want to just put -4 there. So if b is negative, you'll have minus whatever you got for b. Okay, I think we're almost there. Let's see. Okay, I think this is the last problem. Okay, so write an equation of the line containing the given point. This is the worst one. It gives us the most convoluted information here. We're given an equation. Right, so this is what causes confusion for students. They're like, well, here they already gave me the equation right here. What am I looking for? You're looking for a second equation. You're trying to find the equation of a line that contains the point 6, 8, but is parallel to this other line that they give you the equation of. So there's two equations, there's two lines that you're dealing with in this problem. So what I like to do is make a chart to, separate the information. There's the line that I'm looking for the equation of, put a question mark there because I don't know what it is, and there's the line that I'm given the equation of. So for the line that I'm looking for the equation of, what do I know about that line? Well, it contains the point 6, 8, and it's parallel to the line that I'm given the equation of. For the line that I'm given the equation of, what do I know about that one? I have the equation. I have x plus 5y equals 3. I want to find the equation to this line, so I want to use y equals mx plus b. That's the method I like to use. To get started, I need to know the slope, but I only have 1 point here. That's not enough information for me to find the slope using the formula that we did in the last example. So what I have to do is use this other equation that I was given, find the slope of this using the equation, and then use the fact that it's parallel to help me find the slope of the line that I'm looking for. Right, so I know it's a lot of hoops to jump through, but that's what has to be done here. So to find the slope of this line, I'm going to have to solve it for y again, just like we did earlier. So subtract x from both sides. Get 5y is equal to 3 minus x. Divide by 5. Again, the 5 divides into both of these. I'm going to go a little bit quicker here and just write the result down since we've already done this a couple times. So the way you want to set it up and format it is like this. 3/5 minus 1/5 x, right? We put the x off to the side of the fraction. And so my slope here is negative 1/5. It's parallel, this line is parallel to the line that I'm looking for. So the line I'm looking for would have to have the same slope, right? For lines to be parallel, the slopes have to be the same. And so the slope here would have to also be negative 1/5. So now that I know my slope, I can go ahead and plug it in for m. I still need to find b, which is the y-intercept. They didn't tell me the y-intercept, so I'm going to have to plug this in for x and y and solve for b. And this one's going to get kind of nasty, right? Because that 6 is not going to cancel out with this 5, which means we're going to get fractions that we're going to have to deal with, and the answer is going to be a fraction. Unfortunately, that's going to happen sometimes. So I'll plug in 8 for y, and I'm going to plug in 6 for x. All right, so let's kind of wall this off here. And now I need to solve this for b. This doesn't cancel, so I need to just multiply these together. I'll get 8 equals negative 6 over 5 plus b. And let's continue up over here. I'm going to add the 6/5 to the other side. So I'll get 8 plus 6/5 equals b, right? So I'm just adding this over here to the other side. And then I need to get a common denominator. The common denominator here is going to be 5, so I'll multiply 5 to the top and bottom here. So I'll get 40 over 5 plus 6 over 5 is equal to b. Now I can add these together. 40 plus 6 is 46 over the common denominator, which is 5. And so finally, I found my value for b. So we're going to plug it back in to our formula over here. So my final answer is going to be y equals negative 1/5 x plus 46 over 5. And that is the equation for the line that is parallel to x plus 5y equals 3 and contains the point 6 comma 8.